And then hopefully you remembered how to multiply matrices. And just kind of a refresher that this is your x coordinates and this is your y coordinate. So if you take a look here, the only thing that changed from here to here is what? Does anybody notice? What changed? Yes.
The top one was multiplied by negative 1.
Yeah, the top row all became their opposites, which kind of tells you what kind of reflection, that all the x coordinates became negative. Remember? Right, all the x coordinates went to their opposite, so they went over what axes? Y axis, if the x coordinates change. So that's kind of what you're looking at today. More questions on that? You good? Okay. Line of reflection, which we talked about already in the exploration. It's really just, I like to use the word a mirror, basically the mirror. The mirror line used to reflect an image. All right, so you're going to use matrices today, but for right now, we're not going to start with doing the matrices. We're going to just kind of reflect these images. So it says the vertices. What's a vertice? Anybody know? Yes, Annie. Yeah, in a polygon, it's basically the corners of a polygon, right? Triangle, square, rectangle, pentagon, whatever. So the vertices of triangle DEF are these ordered pairs right here. Graph the reflection of triangle DEF described in the line M, y equals 2. Before we get too far, let's just plot these points. So it says we're going to reflect this over the line y equals 2, which is right here. So I'm just going to kind of draw this. It's line M where y equals 2. That's line M. Okay, so there's nothing really tricky here. All you do is look at how far the point is from the line and reflect over the same distance. So just do each point at a time. Instead of looking at as a shape, look at its vertices. So F is how far away from the line? 1. So I'm going to go to the other side of the line and put F prime. And then E is somebody's phone. It's probably mine, sorry. That's on the video, whatever. E is 2 away from the line, so I'm going to go 2 down this way. E prime. And then does D do any reflecting at all? No, it stays on the line. So D prime is also on the line. So then I just connect them. And it looks like that. Kind of cool, huh? That's the reflection over y equals 2. Though there's nothing significant about what happens to their coordinates, let's just write them down and see. D prime, E prime, and F prime. So D prime stayed the same. E prime is over 1 up 0. F prime is over 3 up 3. Their y coordinates did stay the same. Excuse me, the x coordinates stayed the same. Yes, the x coordinates stayed the same, but that's it. All right. So let's do this next one. It's not really all that different. You're still going to start with DEF. So plot DEF, the original DEF. The line of reflection is x equals negative 1, so that's kind of right here. That's line N, x equals negative 1. What's going to stay the same here, the x coordinates or the y coordinates? The y coordinates stay the same. The x coordinates change. So this is 1 away from the line, so there's my D prime. This is 2 away, so I'm going to go over here. E prime. 2, 3, 4. 1, 2, 3, 4. And F prime. Each vertice at a time. Nifty, huh? Not too bad. We don't really need to write the ordered pairs down. Alrighty, turn it over. So these are some rules, coordinate rules for reflections. So you don't necessarily always have to graph it. If you can just remember these rules. Yeah. Sorry. All right. So you don't necessarily always have to graph it if you can kind of remember these rules. And you guys you explored them yesterday. Basically, if AB is reflected in the x-axis, this right here, its image is the point. Okay, so do the x coordinates change if it goes over this axis? No, so they stay the same, but what does change? The B coordinate here becomes its opposite. So if you started down here, the x coordinate would still stay the same, but the B coordinate would go from negative to positive. Just becomes its opposite. So if you have a shape here that's reflected over the y-axis, does the y change?
Yeah. No.
No, but the A goes to its opposite. So negative AB. Do you remember if AB is reflected in this line, its image is the point what? What happens to the coordinates? They flip-flop. They flip-flop. And then, if it's reflected in y equals negative x, the image is the point what? Remember? They flip-flop and they do what? Negative. Yeah, they go to opposite. So those are just some rules to kind of keep in mind while you're doing these reflections. All right. The endpoints of segment AB are 3, 2, and 4, 1. Reflect the segment in the lines and graph the segment and its image. So let's start by graphing this segment. It means it's not a line, it's just a segment. Over 3 up 2, there's A. Over 4 up 1, there's B. Just a short little tiny segment. And I'm going to reflect it. You don't have to draw the line, but I'm going to reflect it over this y equals x line. So if it's going over y equals x, what do I do to the coordinates? You flip-flop them. So the coordinates of A were 3, 2. Coordinates of the reflection is going to be 2, 3. Over 2, up 3. There's A prime. The pre-image was 4, 1. The image will be what? 1, 4. There we go. Don't necessarily always have to draw that line of reflection, but sometimes it's good visual. All right, same thing for this. Let's start with segment AB in the same spot that it was. Over 3, up 2. Over 4, up 1. This was 3, 2, and 4, 1. Okay, so this time we're going to go over y equals negative x. What does it say to do to your coordinates? What do? They're going to go from this quadrant to where? This quadrant, aren't they? In this quadrant, both A and B are negative, aren't they? So you flip-flop them and you change their sign to the opposite. So A is going to become negative 2, negative 3. And B is going to become negative 1, negative 4.
Do you have to write the coordinates?
Not sure. Probably not. You're going to be doing a lot of these on your homework, so you don't always have to write the coordinates, no. Okay? Doable?
Yep.
You won't have any homework Friday. You know why?
We have
Because you have a quiz.
It's just like small in the top.
Yes, it's only 4 sections. It's not the whole chapter. Okay? Yes.
Us. Oh yeah. Drivers and divers won't be here because we have SECs on Friday.
Well, then you can take it Thursday.
Lucky
After school, during
Oh.
I would take it during class. I'll give you the review the day before. Yeah.
What do they do when they school?
So now we're going to use matrix multiplication to come up with the reflection matrix. So remember, reflection in the x-axis. So remember, the first row is representing the x-coordinates. And the second row represents what happens to the y-coordinates. Basically, it represents the y-coordinates. So just kind of keep that in mind when you set up a matrix. It doesn't really pertain to these here, but you'll see what happens. All right, the vertices of PQR are these points. Find the reflection of PQR in the x-axis using the matrix. Graph PQR and its image. So let's graph PQR first, and then we'll set up the matrices. Okay, so it would really be easy to just do this over the graph, but we're going to practice using a matrices to come up with the new coordinates. So remember, you have to set up the matrices for PQR. Remember, the x-coordinates go first, so this is negative 3, 6 for point P. Q is negative 5, 3, and R is negative 1, 2. So this is a 2 by 3. Let's keep that in mind. Now, if I've got to reflect it over the x-axis using matrices, I need to multiply it by this one. But before we write anything down, stop a second and say, if I write this one here, and this is a 2 by 2, is it defined? No, it's not. If you write the 2 by 2 here and try and multiply them that way, it's not defined. You can't say, well, I guess I can't multiply them, because you can. Where do you put this matrix so you can multiply them? In the front. Because then it'll be 2 by 2 on the inside, and it'll be defined. So you put this matrix in the front.
Will we have the matrix on the test?
I don't know. I have to look. It's not too bad. Think about this matrix. Sabina just said, will you give this on a test? Well, look at what's happening. When you reflect over the x-axis, what coordinate changes? The y. See? Look. That's why that's negative 1. The y coordinate changes to its opposite. The x coordinates stay the same. Yes? Look what happens when we multiply. All right, so let's multiply. We're going to have a 2 by 3 in our answer. Each row by each column. This is Jill's favorite thing to do. Each row by each column. So 1 times negative 3 plus 0. What's 1 times negative 3 plus 0? Oh, look, it stays the same. First row by second column. 1 times negative 5 plus 0. Negative 5.
Why don't you branch? Like you
Because you have to use the matrix here. Okay? 1 times negative 1 is negative 1 plus 0 is negative 1. The x-coordinates stay the same. We knew that going over the x-axis. But the y-coordinates all go to their what? Yeah, and we can just make sure that happens. 0 times negative 3 is 0. 1 times negative 1 times 6 is negative 6. Yes. So now we're going to plot these coordinates. We have negative 3, negative 6. This is P prime, Q prime, R prime. Negative 5, negative 3. Negative 1, negative 3.
It'd be negative 2.
Just checking.
We're paying attention. Don't you worry. We got your back.
Thank you. All right, plot those points and you'll have your reflection.
Negative.
One, two, three, four, five. Okie dokie. Here's what you get to do for homework. Page 593. You're going to need graph paper. That's it.